So let's dive into our AP exam FRQ prep for this unit on basic differentiation, and we'll see at the end one question on related rates because the skills are so closely tied in with what we're doing today, which is a lot of implicit differentiation. So if you're uncomfortable with that concept, make sure you go back and watch videos related to that idea. So from the 2001 actual AP exam, number 6A, says the function is differentiable for all real numbers. So it's differentiable meaning that there's no breaks in the graph is continuous, and then the graph has no cusps or sharp corners. Okay, the point 3/1/4 is on the graph, and the slope at each point is given by the derivative here. So they're already giving me the derivative, and they're asking me now to find the second derivative and then to plug in this point. So we want the second derivative, and then we will evaluate it at this xy coordinate. Well, since we know the derivative already, we'll just take the derivative on the left and then the derivative on the right. So let's take the derivative of the left side. That's how we typically denote the second derivative. And now for this right side component, notice that we'll be using the product rule. So let's take the derivative of y squared, which is 2y dy dx. Or you may be used to writing it like 2y y prime. Either way. Actually, I want you to, so you might be used to writing it as 2y y prime. But I want to urge you to start writing as dy dx instead of y prime, because it's just a lot more applicable in different problems, especially when it comes to related rates. Well, we'll want to write everything as like dy dt or dx dt or dz dt. So it's just a good habit to be writing your slope in this way. So we got 2y times dy dx. Now we'll multiply by the second term. Plus, now I'm just copying the first term, and I'm taking the derivative of the second, which is just -2. Now that we've found the second derivative, we can clean it up just a little bit. And in our next step, we'll want to plug in our xy values. So we'll use this line to signify evaluated at. That's what the line means. So we found the second derivative, but we're going to evaluate it at the point 3,1/4. This is our x, this is our y. So look at the previous line. Let's see if we have everything that we need. I know that y is going to be 1/4. I know x will be 3. And here I'll plug in y to be 1/4. The question, though, is what is dy dx? I need to plug in something here so that I can get an actual answer for the second derivative. I want you to look carefully at the problem and see if you can figure out what to do with dy dx. So I hope you noticed that actually we're going to use the original, they gave me dy dx in the question, and all we have to do is plug that back in. So before I go and plug in for dy dx, I'll just rewrite this. So I replaced my dy dx with the expression in terms of x and y, so that in my next step I can plug in. Evaluate it at this point gives me, now I'm going to go ahead and plug in. So 2 times y, that's 1/4, times y squared, that's 1/4 squared, times 6 minus 2x, x is 3, times 6 minus 2x again, minus 2 times 1/4 squared. So I'm noticing right away I can simplify these fractions, but I'll be multiplying by 6 minus 6 is 0. So this entire first term just collapses to 0. Minus 1/4 squared is 1/16 times negative 2, that's negative 2 over 16. So our final answer is negative 1/8. And that needs the left-hand side, of course. And we're done. Let's compare our answer against the AP rubric. So on the AP exam, you can see the work. Okay, we got the correct answer. And they also show the 2 steps that were required. So first, you had to find the second derivative. Then you had to evaluate it at the point. And we did both of these steps. Let's see how they graded. So you can see that this was worth 3 points. 2 points were for getting the second derivative correct. Now, it says here, if you made a product rule or a chain rule error, even if everything else was fine, you lost both points. So really important to get those chain rule and product rule without any mistakes. And then finally, you got a last point just for plugging in the 3 and the 1/4. So if you had made the error here, it's impossible to get the last point because you're not going to get the value correct.